Okay, let's take a look at this. Looks like you've just found the S, sample standard deviation, and then they give us X bar, which we'll need. Um, let's see. Got my picture here, and I'm gonna fill in the percents for this here in a little bit. Exactly in the middle is going to be X bar, which X bar they tell us is 0.84. Now over here, this is going to be X bar plus 1 standard deviation. This is S. Well, X bar is 0.84 plus the standard deviation we said was 0.069. Probably sorry. Well, let me use a calculator. It's nice to screw that up, I guess. There we go. 0.84 plus 0.069. So this is 0.909. The next one here will be X bar plus 2S. Now what we do is we keep adding 0.069 over and over. So we're going to add 0.069 to this. So we're going to have 0.909 plus 0.069, and that gives us 0.978. And then the next one will be X bar plus 3 standard deviations. And again, we keep adding the 0.069 over and over. So I'm going to have 0.978 plus 0.069. 1.047. Okay, over on this side, we're going to have X bar minus 1 standard deviation. So we're going to have 0.84 minus 0.069. So we got 0.84 minus 0.069, and we get 0.771. Then the next one will be X bar minus 2 standard deviations. So what we do is we keep subtracting 0.069. So I do minus 0.069, and that gives us 0.702. And then this one will be X bar minus 3 standard deviations, and again we're going to keep subtracting 0.069. So minus 0.069. We get 0.633. Okay, so that's how we get the numbers down here. You start with your mean, you keep adding your standard deviation over and over, and you keep subtracting your standard deviation over and over. Let me see. Elementary statistics. Section 3.2. Hopefully I pick the one that isn't corrupt. Let's try that one. That's corrupt. Let's try this one. Yeah, that might work. Okay, now here's our percentages. These middle two bars are each 34%. So this one right here is 34%. This one right here is 34%. 13.5. So this is 13.5%. And this one will be 13.5%. Next one is 2.35%. So this is 0.35%. And this is 2.35%. And then the last one is 0.15%. And over here will be 0.15%. Okay, so that's our setup for the empirical rule. Okay. Now it says use the empirical rule to determine the percentage of candies with weights between 0.7 and 0.98. 0.7. Round to 2 decimal places. You put 3 decimal places and it took it. Okay, so I should have used 0.07. Let's try this again. I'm surprised it didn't give you an error on that. Okay, so we got 0.84 plus, and rounding 2 decimal places again will be 0.07, and what is that, 0.91? Yeah, and then I add up 0.07 again, and that gives me 0.98. Then I add 0.7 again, and that gives me 1 point something. 8 decimals. I think 1.05. Let me see. 0.98 plus 0.07. 1.05. Okay, then over here I want to keep subtracting 0.07. So I got 0.84 minus 0.07. I think that's 0.77, but let's see. 0.84 minus 0.07. 0.77. Subtract another 0.07, we get 0.70, I believe, and this one would give us 0.63. Okay, let's go back to our problem now. Between 0.7 and 0.98, the reason why I knew something was wrong is because I didn't see 0.7 on the bottom here. If you don't see what they're asking for on the bottom, it means you set it up wrong. So here's 0.7 to 0.98 would go over to here. So again, it's saying between 0.7 and 0.98. What you do is you add up all these percentages in between those. And that's where they get their 95% at. Now D says, determine the actual percentage of candies that weigh between 0.7 and 0.98 inclusive. This is the empirical rule that tells you in theory. Now, to determine the actual percentage of candies that weigh between 0.7 and 0.98 is a little bit tedious. I may not finish it, but I'll at least start it for you. What you do is we have a total of 50 candies. So you put 50 down here. And you count all the ones that are between 0.7 and 0.98. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Maybe it'd be better to look for the ones that's not between 0.7 and 0.98. Let's see, 0.7, 0.98, 0.7, 0.98. Inclusive means it includes those values, so this 0.98 wouldn't be included. Now here's one that's not. The 0.99, that's not included in there, so that's excluded. I only see the one, which means if there's one that's not between there, then that means there's 49 that's between there. And so then this would give you your percentage. It wants it in percent form, so you need to multiply by 100. Move your decimal place 2 places to the right. Now, if my eyes went off, again, let me see if I can do this in Excel. What's this say? Click the copy table. Open a StatCrunch, copy table to clipboard, and we do copy table to clipboard. And we bring up Excel. And do a paste. Okay, there's our numbers. And let me do a count. So I do equals count if range is A1 through A50, I'm assuming, comma, criteria. sort it. Click this, do sort, smallest, largest. Okay, so between 0.7, well, this falls in there, and over here I got 0.99, so there's only one, which means what I said, 49 over 50 times 100. So equals 49 over 50 times 100. And I'm not sure if that's showing me all the decimal places. Assuming I know how to do those. Where's decimals? There it is. Go bed, I guess. 98%. So the actual percentage of candies that fall between those two values are 98%. And it looks like that's the last question on here. Anyway, that's how to use the empirical rule, and then this is the actual true value of it.